The third approach in base flow separation is variable slope method. Learn how this determines base flow here in hydrology. When we draw a hydrograph, there will always be two parts of the water. The one on top is the direct runoff, which we can use to run our water projects. And the one at the bottom is the base flow, which is the amount of water underneath the grade replenishing streams and rivers. How does variable slope method cut the base flow? Having a standard hydrograph, identify four important points. The first is the start of runoff, where the first extension is based. This extension ends at peak discharge. Now another extension happens from the end of runoff, and this extension ends until the point of inflection. After creating two more points of intersection, they are joined together with a third slope. From the same example, we are to separate the base flow using the third method, which is variable slope approach. The assumptions for this example is the point of runoff start at t as 3 hours. Then peak discharge happens at t of 7 hours. The end of runoff is still at t of 10, and then there's another parameter which deals with the inflection point. This is assumed at t of 8 hours. After plotting each point from the dataset, connect the points, and then work with similar triangles to solve for ordinates. The first direct runoff ordinate is taken from interval of 2 to 3 hours, which is extended until the peak discharge. From the other end, with t of 10 to 11, the curve is extended backwards until it intersects the point of inflection. Connect these two separators. Now create triangles to solve for ordinates. From the small triangle, the y distance is computed as 160 less 140, which gives y of 20. The next ordinates can be solved by placing an opposite triangle. So take the proportion of 20 is to 1 as y is to 1, where y is 20. So the base flow at the fourth hour is 140 minus y of 20, giving 120. For t of 5 hours, the mirrored triangle is longer to cover 2 hours, and by similar triangles, the proportion is 20 is to 1 from the triangle on the left. Then place this in proportion with the triangle on the right, y is to 2 hours. Y is then taken as 40 through cross multiplication. So the base flow is the precipitation of 140, then take out 40 base flow, giving 100. At t of 6 hours, the mirrored triangle has now the ratio of y is to 3 hours, which provides y of 60. The base flow is then 140 minus 60, giving 80. Do the same procedure with t of 7 hours. The mirrored triangle is proportioned to the smaller triangle, giving 20 is to 1 as equal to y is to 4. Y is then 80, making base flow at t of 7 hours equal to 140 minus 80, having 60. After using the first extension, jump on the 10th and 11th hours interval, as the slope of this interval is extended until it intersects the point of inflection, which is at the 8th hour. So if we take per interval computation and work on the right triangle, the y distance is 110 less 95, that is 15. have this proportioned with the mirrored triangle, giving 15:1 as y is to 1, so y is 15. And the base flow at t of 9 hours is 110 plus 15, which is 125. For t of 8 hours, the ratio and proportion involved is then 15:1 as y is to 2, so y is 30. Then the base flow at this hour is 110 plus 30, which is 140. Knowing all base flow coordinates from each hour interval, place another column for base flow, where at t of 3 hours, base flow is 140, followed by 120, 100, 80, 60, then 140, 125, and 110 for t of 10 hours. With the base flow, another column for direct runoff per hour is added to the table. DRH is computed as the difference of the discharge and the base flow. So at t of 3 hours, the discharge is taken wholly as base flow, which means the DRH is 0. For the fourth hour, the DRH is the difference of 190 and 120 base flow, which is 70. At the fifth hour, the DRH is 245 less 100, which is 145 cubic meters. At t of 6 hours, the DRH is 295 minus 80, which gives 215. For the next interval, or t of 7 hours, the DRH is 345 less 60, which gives 285. At t of 8 hours, the DRH is 310 less 140, which is 170. On the ninth hour, the direct runoff is 250 minus 125, which is 125 cubic meters. The 10th hour indicates the end of the runoff, so the discharge is wholly taken as base flow, which means DRH is 0.